in Python, certifications in AI and ML, Microsoft Azure AI fundamental certified, and I have a couple of digital badges as well. Okay, now in recent years we have a buzzword something like artificial intelligence and machine learning, data science. So before going to the technicalities, we will see the difference, what kind of differences we have in between AI and ML. So many people will think that both AI and ML are same, but in reality they are somewhat different. Okay, so first coming to the portion of machine learning, the name itself is saying machine learning. So a machine will learn something from the past and previous experiences. Based on that learning experience, it can predict the future instances. Okay, this might happen in the next instance, or this might happen in the next moment. So if we are able to know the things in advance, we can make the necessary arrangements. Something like if we are able to know that next month something like COVID fourth wave is coming, so we will be ready with the necessary precautionary measures. So if we know the future things in advance, we will be ready for that situations. So machine learning is a kind of technology where it will learn from the past experience, and based on that learning experience, it can predict the future instances. That's what basic thing about the ML is. And coming to the artificial intelligence, here also artificial intelligence is a kind of technology which try to mimic the human behavior. If human is in this particular situation, how he can behave, AI is a such kind of technology to predict the instances and take the corresponding action. For example, we'll see a couple of examples, something like autonomous cars, the trending one in AI. Now, there are many companies they can design the car, but there are only few kind of companies that are able to design the autonomous cars, and that too in certain countries, not all over the world. Okay, because autonomous cars are the final end product where
one question. So machine learning will not take any action.
machine learning machine learning will predict the future instances. In order to take the decisions, in order to make the decisions into reality, we use AI. Okay, for example, if you take the artificial intelligence, autonomous cars is an example, there are many companies which can manufacture the cars, but there are only few companies which can make the autonomous cars. Okay, because a normal car anybody can design, but we need to make a car something which thinks like a human. Backend is machine learning. So we need to integrate the ML technology with the designing of the car or that product design. So these two things together will form an AI product. So AI is a final end product which can think like human by using machine learning and perform the corresponding action. That's what the difference of AI and ML is. You'll take the example of autonomous robots. Normal robot will work according to the instructions, something like button or something like input. So left, right, front, back, such kind of inputs will give. According to that, normal robot will behave. But autonomous robot, it needs to think like human. According to the thinking capability, it needs to perform the action on its own. So normal robotic engineer can make normal robots, but if you want to make an autonomous robot along with the normal robotics, we need to have the ML as the backend. So integration of these two things together form a final AI and product. Hopefully you got the point.
Yeah, so my understanding is like so AI and ML are two different things. AI can exist without machine learning?
No chance. It's a core of AI. Without ML, AI is nothing. But ML cannot make the actions, but AI can make the actions in reality.
Okay, so ML is just a prediction, just a forecast.
It's a kind of prediction and forecasting. That's it.
Got it.
Yeah. For example, in our mobiles, we have Siri or Cortana, OK Google, different kind of voice assistants. Okay, those things are the predictions of ML. But in order to make that voice assistant into reality, we need a device something like mobile phone, or we need a device something like Alexa. That's the final AI product. And
so ML is a subset of AI. AI is the broader.
Yes, of course. AI is the integration of n number of technologies together to form a final end product. And there are no fixed technologies. Depends upon the type of application we are using. We need to integrate different kind of technologies. But ML is remains same. ML is the core one.
So where is the data science comes into picture?
Yeah. I'll come to that particular point. Now, I'll come to that particular point after 10-15 minutes.
Sure, thanks.
Okay, yeah. So in between, I'll try to explain some kind of examples. Okay, now, as I told you, the example of autonomous cars or this kind of voice assistants, okay, or chatbots. So without any human intervention there, there are some chatbots, especially in medical related fields. You can type any kind of queries, automatic response that you can get from that particular website. Okay, there won't be any person sitting and give you the responses. Automatically, those will be generated by an ML algorithm or a deep learning algorithm. Okay, now nowadays in some facial recognition systems, a computer which knows only zeros and one needs to identify whose face it is. It needs to predict whose face it is in front of that particular camera. According to the detection of the face, it can perform the corresponding action. So these are some of the applications of artificial intelligence. Now coming to the machine learning, for example, you can go to the internet and type what could be the weather tomorrow. So it can simply say something like 20, 25 degrees according to that particular country and location. It will give you the temperature details. Or will it going to be rain tomorrow or not? It will give you the simple forecast. And yeah, so these are some of the applications of machine learning. And we have one of the major applications of machine learning is something like recommendation systems. You go to Amazon Prime or Netflix. Okay, there you're looking for any particular video or any particular web series. Okay, if you search for any particular web series, there you can find lot of related web series which are related to your previous search. I think everyone faced the situation. You go to YouTube or look for some tutorial on Python or artificial intelligence. There at the bottom, you can right bottom, you can find n number of related videos which are related to your previous search. There are millions of videos on the YouTube, but why only those kind of recommendations to you? Means an ML algorithm will think, okay, this fellow is interested in this particular video. He might interested in these videos as well. For that reason, they will give the recommendations. That is an ML thing. Recommendation engines we call them as. And something like online social media platforms or online something like a shopping website, Amazon. Okay, for example, if I want to buy any product in Amazon, I want to buy a mobile in Amazon. I look for that particular mobile or TV, whatever it is. Okay, but I didn't buy any product in that particular time frame. But if I go to something like Facebook or Instagram or YouTube, after 5-10 minutes, there I can find some ads which are related to my previous search in the Amazon. I hope you face that kind of situation there.
Yes.
Yeah, those kind of things we call it as recommendations. According to your search history, ML algorithms will recommend you the products. Okay, or in some other case, you bought a mobile in your
How this is connected? So Amazon and my Facebook, how it is connected?
So they are connected with accounts or mobile numbers. You will be logging with the Google, with your mail ID, and with the same mail ID, you will be creating the accounts in the Facebook, or the same thing you can create the accounts with the Amazon.
Okay.
Yeah, so everything is interlinked in this digital era. And same example, same recommendation. We are this time, like when I was looking for a particular mobile, I bought the mobile in that particular time frame. Okay, after a couple of minutes, if I go to minutes hours, it may be. So if I go to same YouTube or Facebook or Instagram, there this time I can see the ads which are related to your previous purchase, something like mobile cases. Okay, if I buy any TV, something like TV related things, we can get the ads. This is one kind of recommendations. Okay, so these are the applications of machine learning. Recommendation engines we call them as. Weather forecasting, these kind of recommendations, such kind of things are the applications of machine learning. I think you get the basic clarity about artificial intelligence and machine learning.
Yes.
Yeah. Okay. Let me start sharing my screen to you because I need to show you the difference between.
Yeah, I have one more question. What is the prerequisite for this course? So before joining the training, what is the prerequisite? What things I have to know before?
So if you know the basic math, that's more than enough to learn the machine learning. But if you want to know the artificial intelligence, ML, and any programming language are mandatory things. For learning machine learning, no prerequisites are required. If you know the basics of any programming language, that's enough. But in order to learn, or you want to be in-depth, gain in-depth knowledge in the artificial intelligence, you must have the knowledge of machine learning for sure. And companies first will prefer the machine learning engineers. Freshers, they'll prefer as the ML engineers because directly people can't develop AI at a time. You need to gain certain amount of knowledge on the machine learning in the reality. Then only they'll be moving into AI engineers or initial stages, but they will be as ML engineers or a data scientist. Okay, if we have certain, if we gain certain amount of experience, then we will be the AI engineers. Got the point?
Got it. Yeah, thank you.
I think, hope you can see my screen. Can you?
Yes.
So can you see the paint white color board?
Yeah.
Yeah. So as we discussed, ML is a kind of technology which can learn something from the experiences. Based on that learning experience, it can predict the future instances. And that ML is the small amount of portion in artificial intelligence, because in AI, for example, you want to design autonomous robot, you need ML. Along with that ML, we need to have the knowledge of robotics. Robotics, nothing but IoT, something like we need to have the knowledge of cloud as well in order to make that final end product.
So RPA is a part of AI.
Can be not exactly it's an direct 100% AI, but it is the process to automate the tasks,
To make action, to perform action.
to perform the predefined actions. Something like we can customize certain kind of actions. It can perform the actions within that certain limit, but it cannot perform all the actions.
Got it.
Okay, so in order to automate the tasks, we'll use RPA. For example, I want to send the emails to the hundreds people. I have 100 photographs and then I have 100 images. So instead of a person can sitting there and sending the emails to each and every individual photograph to each and every candidate, we can automate that process by using RPA. Okay, so we'll give all those images in a folder. We'll give all those mail IDs in an Excel sheet, and we'll write the script once. We'll automate that process by doing one thing. The same process will be repeated in that Excel sheet for 100 number of times. Process automation. It won't predict anything new. It won't like perform any actions, but there are there are many predefined actions. We need to customize them according to that. It will perform the actions. That's it. It's a predefined one, automated task.
Got it.
Yeah. Now, ML is the core portion of AI. So according to the applications, we need to integrate different kind of technologies to form a final AI and product. As I told you, voice assistant, if you want something like Siri or Cortana, you want to design, of course, very high-end things of AI, ML. Literally years of time will take to design such kind of things. Now, as an ML engineer, I can design a system which can convert voice to text or detect my words or detect my vocals, whatever I have spoken. Just a minute. We're having small kind of disturbance for a while. Sorry. Okay, but in order to make that product into reality, I need a mobile app, something like I need a mobile OS, something like iOS or OK Google. I need an Android platform to implement that applications. Or Alexa, voice assistants. So in order to perform Alexa, in order to design, I need to have a device like Alexa. In that particular device, I need to integrate my ML model. So according to your application, the kind of technology in AI will change, but ML remains same, and it is the brain. It's the core portion of AI. Without ML, so it's very difficult. Now, there is a subset of machine learning which we call it as deep learning. Okay, for example, in machine learning, you'll be having around 15 algorithms, but as of now, many people are using around 8 to 10 algorithms only, because some algorithms are outdated and some new data sets are generating. Those old algorithms are not able to work properly. So around 8 to 10 algorithms which will work properly for any kind of data set we'll be having. But whereas in deep learning, okay, we'll be having only 2 to 3 algorithms. Okay, and those 2 to 3 algorithms are derived from these 8 to 10 algorithms only. And this deep learning is the core portion of artificial intelligence. Okay, where deep learning comes from means ML again itself. So deep learning is the core portion of deep learning is the main portion to implement AI systems. But if you want to implement anything in deep learning, of course, we need to get those things from machine learning only. Okay, whereas in machine learning, you'll be having wide variety of options in terms of algorithms. But whereas in deep learning, only 2 to 3 algorithms we have. Now the question comes, what is the machine learning difference between machine learning and again in deep learning? Now,
yes,
yeah, I'll tell you an example. So I need to, okay, in deep learning, the name itself is saying deep learning. Okay, that means it will learn much more deeper than the machine learning. Okay, something like I need to travel from here to US. Okay, I don't have any prior experience of traveling from India to US. I don't have any consultancy, Google Maps, such kind of help. So what I'll do? So first I'll take the reference of any friend. What I need to do? So you need first I need to book the ticket. I need to travel to the airport. I need to get the checks in the immigration. Then I need to board the flight. I need to reach the uh, a final destination, whatever the country it is. Okay, I don't know this process. What I'll do? First, I'll take the reference of any friend or any consultancy. I want to travel to the US. What I need to do? They'll say, okay, first book your visa, then book your ticket, then go to the airport, then perform the task. So this is machine learning. If you don't know anything, you learn something from the data, something from the experience. Now, coming to the deep learning, I need to travel to the US for the first time. I'll take the reference of my friend or some consultancy, whatever it is. Okay, and I finished my journey. After 4 months or 5 months, I need to travel to the US again. Will I take the reference of my friend or that particular consultancy again?
No, we already have the reference.
Yeah, so we already have certain amount of experience during my first journey. Okay, so deep learning is such kind of things where in machine learning we'll be having data, and we'll give that data to an ML algorithm, where that ML algorithm will learn something from the data, and based on that learning experience, it can forecast the future instance. Okay, now coming to the deep learning. Okay, deep learning also process remains same. We'll have the data, we'll give the data to the deep learning algorithm. The deep learning algorithm will learn something and forecast. But before forecast, what it will do is it will come to the initial point and starts learning again. Okay, and it will learn something extra than the first attempt. And again it will learn in the third attempt, which will have the experience of past two experience, so it will learn something more better in the third attempt. So again it will learn in the fourth attempt, which where it has the experience of past three attempts, so it can learn something better than the first three attempts. So fourth attempt it can learn something better. So it's a repetitive process, same data set, same algorithm, but n number of times.
Okay,
So
but we have to start with machine learning. We cannot
yeah,
start only with deep learning,
no,
right?
no chance, no chance. No, with directly deep learning, you can't start, because if you don't have the prior knowledge of machine learning, AI, we can't. Deep learning, if I'm referring, that means AI. Okay, because without deep learning is the core of AI more than machine learning. Okay, can I tell you one more example?
Yeah. I want one example for deep learning.
Yeah. So simple. Tomorrow I have an exam. Sorry, I have an exam tomorrow. Today I need to prepare. I have a syllabus of something like some 5 units. I mean units in the sense 5 subjects. Okay, so what I'll do is I'll sit today night, entire night I'll keep on studying all the 5 units, and I'll complete my preparation. Tomorrow I'll go and perform the exam. So your syllabus is data, your preparation, something you're learning from the data is machine learning. Tomorrow you're performing the exam. Got the process?
Mm-hmm.
Yeah. So you have exam after 10 days, and you have the same 5 units or 5 subjects, and you have 10 days. So what I'll do is today I'll prepare something. Okay, I learn something from my syllabus. Okay, so tomorrow again I'll read. So first day of study, I can't remember all the points. First day of study, I'll try to remember the points which are important, something like side headings and important points only I'll remember. So tomorrow what I'll do is I'll revise again. So what can happen tomorrow if I revise again? So already I have a knowledge of those important points which I learned in the first day. Second day I can focus more on the other points rather than those important points.
Got it. So it's like reading a book.
Reading
So
a book.
first day I read just a few pages,
Mm.
or maybe skipping the pages to
Mm.
understand what the book is about. And the second day,
Yes,
third day,
exactly.
I will deep dive into the book.
Yeah, exactly. So
Okay.
first day I don't have any prior experience, so I started from zero. But second day I have an experience of 1 day study. So with that help of 1 day experience, second day I'll try to become somewhat better than the first day.
Mm.
Third day something better, fourth day something better, fifth day something better. The point you need to remember here is same data, same algorithm, but you need to repeat the same task for n number of times. That means time taking process, but you can learn something better than machine learning.
Okay. What is the assurance? Reading the book first time and reading book second time, third time.
Hmm.
Okay, I agree. First
Hmm.
time and second time, definitely,
Hmm.
I will
Hmm.
be making some improvement. But
Uh,
after 10 times, after 50 times, the same thing, right?
Yeah, but in terms of book, it's the same thing. For example, if you take an Excel sheet of 1,000 rows, at the first instant, we can't read about an algorithm can't completely get the 100% learning experience from that particular 100,000 rows of data. And imagine if you have 1 lakh rows of data. At the first instance, algorithm cannot get the things completely. It will give you some result even after the first attempt. I mean, after first learning stage of the first iteration. But that may not be 100% accurate, or that may not be proper.
Got it.
Yeah. So, for example, even if you have an Excel sheet, 1 lakh rows, hardly that will be something like 20 KB, 25 KB file. That's it, right? But
Yes.
if we have an image, I want to design a system which can identify facial recognitions. Okay, if I go in front of the camera, it needs to detect as Rajesh. If I train my model with Randy, if you go in front of the camera, it needs to detect as Randy. That means it needs to segregate the difference between you and me. Now, if I capture a photograph of mine with an iPhone, what could be the size of that particular photograph? It could be around 5 to 6 MB. A normal, without any basic thing, 5 to 6 MB. If we have 1 lakh rows, the Excel set should be something like 20 KB or 30 KB. But if I take a photograph, that photograph itself is the 5 MB or 6 MB. That means that photograph consisting of that much huge information in a single photograph. If you want to design a facial recognition system, even 10,000 photos we have, that's an average data set. I can't say it's an 100% wonderful data. That's an average data set. And if you have that much huge data, just by learning from the single instance, it can't give the output, predict the output properly.
Got it.
Yeah. So the data is becoming huge. There we need more amount of learning. So hopefully you got the difference between machine learning and deep learning.
Yes.
Yeah. And there are a lot of algorithms available in machine learning, and we won't implement all the algorithms in deep learning because there are certain stages or there are certain requirements where we can apply machine learning. There are certain things there we can apply deep learning. I'll go to that point after a bit, and I'll tell you the difference between data science as well. Okay. Now, artificial intelligence, machine learning, and deep learning, these three are interrelated and dependent to each other, especially deep learning on machine learning, artificial intelligence on deep learning. Okay, if you wanted to implement artificial intelligence or machine learning in reality, we need to, the prime requirement for artificial intelligence and machine learning is data availability. Okay, so to tell this point, we have initial machine learning algorithms around in 1960s and 1950s. In between, we have the first machine learning and deep learning algorithms. But if we properly observe, recent decades only we are having this artificial intelligence and machine learning implementations in reality. Even though the algorithm is first algorithm available from 1950s, it will take around 40-50 years to make it into the reality. Why that much use span means nowadays only the data generation has been increased. Just imagine daily how many comments we are making, something like Facebook or Instagram or YouTube or Amazon. We buy any product, we are making some comment on that. Nothing but the data. How many photographs we are uploading? How much amount of videos CC cameras are capturing daily? Right. So in this digital era only the data generation has been increased. So AI and ML is a kind of technology make use of the data to predict the future instances.
Big data.
Yeah, big data. Big data is a kind of thing to store the data because the data generation has been increased where we can store this data, not in our laptops or pen drives or systems, right? So we need something extra to store that kind of data. There, big data comes into the picture. Excuse me. Now, so here a question comes: what is data? So data is nothing but information that could be in any form. For example, I have some 10 students details, something like name, mobile number, and something like email ID, first name, last name, father name, some basic details I have. Nothing but I
Even
have some
images,
data.
right? Even images,
Yeah,
some
yeah.
other
So
type of
those are
data.
the data. I have data in the form of Excel sheet or a text document, which is nothing but the data. I have images of 10 students, nothing but the data. Or I have call recordings or audios of 10 students or some 50 students, nothing but the data. Just a second. Okay, so all these are the data, but those can be in different kind of forms. Okay, so now the question comes: when we can use machine learning, when we can use deep learning. Okay, now if you have 1 lakh rows of data, hardly that Excel file size could be around 50 KB or 60 KB. That's it. Or a text file, if you have 1 lakh rows of data, that could be around 50 KB or 60 KB. But if we have a single image, how much? Around 5 6 MB with the normal cameras. If something like DSLR, that could be 20 MB, 30 MB. Okay. And if we have a normal call recording, that would be around 2 to 3 MB. Just 2 to 3 minutes of recording will have 2 to 3 MB of size. Okay, now a simple question: whether this 1 lakh rows of Excel sheet or text document consisting of more amount of information, or this image or audio consisting of more amount of information?
The image, sorry, audio, video.
Obviously, audio or video or these images will be consisting of more amount of information. So 90%, I'm not saying 100%, 90% of the cases when we have the data in the form of Excel sheet or the text document, less data, okay, less data in terms of less size data, there ML is the most suitable option there. Okay, but if you have the data in the form of images and audio, their deep learning is the most suitable. I'm saying most suitable. I'm not saying that ML is not at all suitable. Of course, ML is suitable, but the training is not sufficient if you have the data in the form of images or audio. So their deep learning is the most suitable option.
Got it.
Yeah, and if you perform an ML model and you get your result as something like 80%, okay, just by studying in a single night, you'll get the 80% in your exam, 80% in your result. Okay, to be frank, it's a wonderful model because just by learning a single instant, if you are able to predict 80% correct answers, that's a wonderful thing.
Wonderful.
Just wonderful thing. Okay, and in ML, that's a acceptable thing. But when coming to the deep learning, okay, that means you're preparing for your exam from the past 10 days. That means you're training and revising 10 days you're performing the same thing and you got the 80%. Not preferable that much. Agreed?
No.
So the same thing happens in the reality. So if you have a small amount of data, you'll try one time by using machine learning things and you'll get the 80% of accuracy here. Okay, that is acceptable for sure. If we try to, we'll try to improve. If it's improved, very good. Even if it's not improved, fair enough.
Yeah, we are still okay with that.
Still okay with that, but just by simple learning only we're getting 80% means if we give the heavy training, we can get the better result. But whereas we are giving our training to our algorithm by learning the same data set again and again and again, still we are getting 80% means not preferable. Okay, in deep learning, and that too, deep learning will be used where we need exact pinpoint result. Something like facial recognition, it needs to identify correct face 100%. Because it's a security related thing. And coming to this kind of application, something like Siri or Alexa or something like OK Google or Cortana, these kind of applications, they need to predict whatever the word that we have spoken. Exactly 100% word needs to be identified properly. Yeah. So deep learning is a thing where we need 100% exact prediction. So such kind of how we can say, such kind of applications we can use deep learning. But coming to the machine learning, of course, getting good accuracy is okay anywhere. But something like I want to predict the tomorrow's temperature. In India, as of now, temperatures are something like 20, 21 degrees, such kind of temperatures we have. Now, tomorrow's temperature, I predict something like 20 degrees. But in reality, it is 21 degree. Still, it's a good prediction. 1 degree of variation, not that much different thing. But coming to the facial recognition system, so if I go stand in front of the camera, if it is identified as a Randy, even that minute wrong prediction matters a lot in deep learning.
Got it.
So deep learning will be used if your data set is in the form of images or audios, and if you have target or if you have business problem of excuse me.
So, okay. You mean to say deep learning will give you 100% accuracy?
That we need to train. Okay, we can't say that we'll get 100% every time, but 80% is not at all sufficient. That we can train. That we can say. What are the things that we can more than 95? That could be better. That depends upon the data set availability. If your data is not good, even with the deep learning, we can't get 100% accuracy. So as an ML engineer, our task is to try improve this accuracy.
Got it.
Yeah. So like we're building an ML model means what? So first we'll build a basic code with the data set. Then we'll try improve that to whatever the level or whatever the stage it is possible. But whereas in deep learning, if you stop at 80%, that may not be the preferable solution. We need to aim more than 90-95%. That is the preferable solution in deep learning. So at the time of like students or basic kind of academic projects, then 80% is fine. But we want to make the real-time applications, 80% is not at all sufficient. So I'll tell you. I worked on a project called ECG analysis. You're aware of ECG, right? Electronic
Yes.
cardiogram mission.
Yes.
Yeah. So just by looking at the images, every time a doctor may or may not available at all the situations. Okay. So especially in India, we have ECG mission somewhere in some hospital and doctor will be somewhere. So there will be a time gap in between this test and that doctor evaluation. There is a time gap. So anything can happen in between this time gap, right? So we got a project when I was in that my previous company. Like we got a project something like ECG analysis, where we'll be getting ECG images from certain hospitals. Okay, where some images might be of heart attack cases, some images might be of not heart attack cases. Okay, so I was in a situation to train my model, deep learning model. Of course, it's a deep learning model. So I'll give my algorithm that okay, these 100 images are heart attack images, these 100 images are not heart attack attacked images. So I tried my deep learning algorithm, and in future, if I give a new ECG image to my algorithm needs to tell whether this particular ECG candidate will get the heart attack or not. Got the point?
Yeah.
So their accuracy 80% means out of 100 predictions, 80 will be correct, 20 will be wrong. So they're like how much accuracy plays major role. That's what I want to tell. If I say that this particular candidate won't get the heart attack because okay, 80% is fine enough, but there is a 20% chance that what if that particular candidate got the heart attack? Right. So like deep learning will be used where we have pinpoint applications. Or I need to predict the things exact. There we'll use deep learning. Okay. And if we have the data in the form of Excel sheet and text format, majority cases machine learning is enough. Majority cases machine learning is enough, except one or two applications. And if your data is in the form of images or audio, majority cases deep learning is the preferable training method out there. Yeah.
Got it. So one question. So
Yes.
deep learning, you said we have to do multiple iterations.
Yes.
So when can we deploy this? Say for example, so first time we are getting only 10% result accuracy, then keep on improving. So when will you deploy this product to the customers?
So like once we train our model, okay, that's the point I want to come. Okay, so I'll show you the 1 second. Pipeline. If we have a project, how we can do that project in machine learning or deep learning, that we'll see. Okay, here I'll explain you the proper thing. Sorry, just a minute. Okay, whether you have the machine learning model or a deep learning model, this is the project flow. Okay, so if you want to start a machine learning or a deep learning model, as I told you, the prime requirement is data set availability. Okay, so if we have the data, then only we can train the algorithm. If you don't have the data, even though we have the first machine learning algorithm around 1950s, but the implementation started only in reality started in the recent decades only, because at those kind of times we don't have the data sets. Everything will be written on a pen and paper. That's it, right? We don't have any records in the systems or computers. But nowadays, everything is in computer only. We can save the data set. So ML or a deep learning is a kind of technology which can use this data to predict the future instances. So data is the prime requirement. Without data, to be frank, no need to think about artificial intelligence and machine learning. And now the another requirement of a machine learning or a deep learning model or AI model is business problem. What we need to do with the data. For example, I have a data set of some hospital related things, patients and their medical records I have. Okay. Now, with that data, if some client asks me to find out his wealth or his property, is that a valid point?
Yeah.
So according to the patient medical history, can we predict their financial status?
No,
No,
way. No way.
no chance, right? So here, data is the important thing, and what we need to do with the data, business problem, what we can predict with the data. For example, I have the patient medical history. Based on that, I can predict whether that particular patient will be getting something like heart attack or not. I can predict whether that particular candidate will be getting something like diabetes or not. Then that's a valid case. So in order to start a machine learning or a deep learning project, we need to have the data. We need to have the business problem. Business problem in the sense what we need to predict and a valid relation between these two. If we have these two things and a valid relation, then only we can start off a project. If we don't have any of these things, we can't start a project. You have the data, we don't know what to do. What we'll do with this particular data set,
Got
right?
it.
Yeah. So data is required thing. Along with that, we need to have the business problem and a valid relation. I have something like climate data, something like whether we'll get the rain tomorrow or not, something like we'll get the thunderstorms or not. That kind of data set I have. But based on that, I can't predict whether this particular candidate will get the 100% in their academics or not. Right? Not related things.
Yeah, got
A
it.
valid relation is required. So if you have these two things, for example, if we are working as a software engineer or ML or AI engineer, okay, you got some project. And the first question we should ask is, do you have the data or not? Instead of commercials, definitely we should ask, we have the data or not? If they said they have the data, what we need to do that data? They said, okay, these are the business problem. These are the things we need to do. Then we need to discuss about this something. Even though the project is more than what we expected in terms of commercials, if they don't have the data, we can't even start.
Yes, got it.
Yeah. Now we have the data and business problem and a valid relation over there. Now the primary step, the first step is data collection. Data collection is a kind of step. We can't say that data everyone will give you in the terms of pen drives or laptops or computers. Some might give you data by using databases, something like MySQL or Oracle SQL, DBMS. Some might store data in the servers. Some might store data in the cloud, something like big data you told, right?
Mm-hmm.
Someone store the data in data warehouses. Okay, so we need to know how we can extract the data from the particular thing. They'll give their database login credentials. We need to extract the data from there. But majority of the cases, they'll give you the data. Okay, because they'll be having huge amount of data. They won't give everything to us. Okay, they'll give whatever we want. So data collection is a kind of thing. Wherever the data we have, we need to get. If you have data in terms of pen drive or a laptop, that's very simple. Or if you can directly download from the data from the Google, not an issue. This particular step is done. But if we have the data from database, okay, we need to extract the data from database. What are the features that what are the elements we want from that particular database? We need to get those things. Okay, that's the first step. Now we have the data. Well, it could be from database or server or warehouse, wherever it is, we got the data. Now, then the next point is data understanding or data visualization. Data understanding in the sense, so here we have a problem, something like there is a valid relation must required from the data and the business problem, right? The same thing in data, for example, 1 lakh rows we have. Okay, out of those 1 lakh rows, they will be having around 100 columns. Okay, out of those 100 columns, some 10 to 15 columns are not, if we don't require those kind of things, according to our business problem, those are not at all related to our business problem. Why would we give those unwanted columns to our algorithm to learn? So we can remove them, right?
Yes.
Got the point or not?
Yeah, got it.
So data understanding is a kind of thing where we need to observe data, okay, and what kind of data they have given, how our data is behaving. For example, I have two things, X and Y. Okay, just imagine this one as an Excel sheet of 2 rows only. Wait a minute. 1, 2, 4, 3, 5, 4, 7. Just by looking at this X and Y, can we find out any valid relation here? To be frank,
No.
Just by looking at these 4 or 5 rows, okay, we can get basic detailing. But if you have 1 lakh rows or something like 1,000 rows or 1 lakh rows, we can't get any valid relation over here. But if I plot x-axis, y-axis, when x value is 1, y value is 2. This is the point. When x value is 2, y value is 4. This is the point. When x value is 3, y value is 5. When x value is 4, y value is 7. Okay, after plotting, I
Yeah,
can say that the data is increasing.
yeah, it's keep going up. So it's a
Increasing,
good.
right? Yeah. So that's what data visualization is. We can observe the behavior of the data just by plotting. If 1000 rows are there, only 2 columns I have taken, but we have 10 columns. Just by looking at the data, we can't understand how your data behaving. But if you plot that, you can understand few insights from your data set. So this is a kind of step where we need to understand what kind of data we got, what kind of rows we have, what kind of columns we have, how much those rows or columns are important to our business problem. Some there might be some columns which are not at all related to our business problem. There might be some columns which are very much related to our business problem. Okay, so understanding about your data set just by plotting or by performing some mathematical or statistical operations here. Yeah, that's what the next step is. Data understanding. Now, data pre-processing. Third step is data pre-processing, the core part of any project in machine learning and deep learning. Data pre-processing is, excuse me, data pre-processing means we can't directly give the raw data set to an algorithm. Algorithm won't accept raw data set. Raw data set is in sense something like, again, I'll take an example. I have 2 columns, X and Y. Okay, 1, 2, 3, 0, 5. I have 0, 1, 2, 4. I have. For example, in this Y, this is 0. Okay, this is 1. This is 2. But by mistake, this 0 is typed as O, character O. Okay, this one is 4. You got the point? So this one is a number. That above 0 is a number where that 0, last but 1 0 is a character. O, alphabetical character O. If you open an Excel sheet and look for our eyes, 0 and O's seems like same. But an algorithm, this entire column is of numbers except this particular one. So algorithm won't accept this particular character, so it won't train. Got the point or not?
Right. Yes.
Right. So this is the mistake, maybe human mistake, just typing mistake or something. So instead of 0, O is typed. So this entire column is of numbers, one character is there. We need to identify where the error comes, because of which element we got the error, and we need to convert the 0 to O. That means raw data set you have, that raw data set directly you can't give it an algorithm. You need to pre-process that. Something like you have the raw vegetables, we can't eat them directly. So we have a process of cooking, something like cleaning and peeling, then cooking. There is a process, right? The same thing, you have a data set. Unfortunately, there, look here some space is there. Instead of some numbers or characters, here we have some space, empty space left over there. Algorithm won't take that empty space. It will give you an error. And imagine 1 lakh rows and 100 columns we have. It will tell you have the error, but it won't tell you where it is.
So we will get the incorrect results.
No. Algorithm won't even start learning.
Okay.
So we need to identify where that particular empty space is. We need to detect and we need to resolve that issue. Just by deleting the row, that issue will be resolved. Or just by deleting the column, that issue will be resolved. Or just by replacing those values.
Sorry for interruption. Actually, Randy and Rajesh.
Yes.
We are getting like running out of time.
Okay.
And we have other things to be settled. And we are good to go with you, Rajesh. And I'll try to reach you, and we'll schedule from there, and we'll plan from there. Okay.
Just give me 2 minutes. I'll tell the difference between data science and machine learning and artificial intelligence.
Sure.
I'll conclude that. Yeah.
Sure.
So data pre-processing. Please don't mind. I don't want to stop in between, and you're asking questions very interesting.
You can take only.
So data pre-processing is a kind of thing. Make data properly and give it to the algorithm. Then only algorithm will start learning. So this is the portion where if data is images, deep learning comes, or if data is text, something like machine learning comes. Here, at this particular point, we'll train our machine learning model. And model evaluation is a kind of step where can we increase the accuracy of that particular model. or if we make any kind of mistakes in the data pre-processing, we'll try check them, or we'll try update them, and we'll try to build the model again, and we'll check the algorithm performance. Because how can we trust the algorithm directly? It's just a machine saying that this will happen. We can't trust that directly, right? So we need to check multiple ways whether that result is correct or not. Can we improve that accuracy or not? So model evaluation is kind of step to improve the algorithm performance. And for example, if you say 80% we are getting the correct answers, okay, we'll show this particular 80% to the client. If he said 80% is okay for us, then we'll go for the deployment. If client asks, okay, 80% is not that much good, then we'll try improve that again. We'll try to get that, we'll try improve that up to a particular point, then we'll show it to the client. If they say it's okay, 90% is okay, then we'll deploy the point. Unless until client accepts that, we won't deploy them directly, right?
Got it.
Yeah. And if you observe these first 3 steps here, I didn't talk about anything called machine learning or deep learning.
This is just a data.
This is just data and data understanding, data visualizations. These three things I'm talking about ML, right? So ML engineer is a kind of person who will work with machine learning models and accuracies and performance evaluation and all. That particular kind is ML engineer, where the initial step, these 3 steps will be done by a person called data analyst, where he has the responsibility of getting the data, understanding the data, giving proper insights, and perform the pre-processing step. This could be a task of ML engineer or data analyst according to the requirement. Okay, so if a person is able to perform this entire task, that particular candidate will be called as a data scientist.
Got it.
Got the point? So data scientist is a person can handle the data and can handle the models as well.
So it can be ML or deep learning.
Can be ML or deep learning. Can be ML or deep learning, anything.
Okay, data scientists should be able to do both.
Yeah, both. Again, they need to have the understanding about the databases. They need to have the understanding about something like cloud. They need to have the understanding about something like big data. May not have the 100%, but at least they should have the knowledge, because sometimes they need to fetch the data, right?
Got it.
Yeah. So that's what the basic functional difference between data scientist, data analyst, ML engineer, and AI engineer and all.
So what is the technology behind it?
So
technical side.
Yeah, this entire process can be done by using Python. Okay, nowadays we are getting tools as well, and we have R programming language. We have a number of resources that the cloud service were available. But you wanted to learn this service directly, we're calling it's a kind of API. We're calling that, we're using that, but we don't know how it happens. So you want to do this kind of things. There are a number of things, but best preferable things are Python. Okay, because this data analytics thing we can do in Python, this ML model thing or deep learning model thing that we can do it in Python. So for that reason, majority of the times we'll go with the Python. And with this I'll conclude. I'll divide this course into 4 major things. With this I'll conclude. Abhay, please don't mind. Okay, so first I'll start with Python. Okay, basics. If they know basic Python, this portion can be excluded. After that, advanced Python. What's the Python that required for machine learning and deep learning? That we'll discuss. Advanced Python and data analysis by using Python. Third portion is ML algorithms and the implementation. Fourth portion is deep learning algorithms and implementation, deep learning or AI. Okay, if they're aware of Python directly, I can start from advanced Python, machine learning algorithms, and artificial intelligence algorithms and their implementations. Of course, without real-time provides anything, we can't say that it's completed. If they don't know Python, we need to start from this particular point onwards.
Got it.
Yeah. So that's it from my end. Sorry, Abhinay, for this.
It's okay. It's okay. Not an issue. It's okay.
Any questions?